All right, so our next section, we're going to solve each equation over complex numbers. So if these directions sound a little confusing, we're just solving the equation. When it says over complex numbers, that's just a heads up that we're going to get a complex number in our solution, which means that we can expect I to show up. All right, so we have x squared equals negative 81. To get the x alone, we just square root both sides of that equation. The square root of x squared is just x. And then one thing we have to remember is that these quadratic equations do have two solutions. So that's when we bring in our plus or minus. There's nothing that reminds us to bring in a plus or minus, but that's how we get the two solutions. If we forget that, we're only providing one of the solutions, which technically is only half of the answer. And then when we square root a negative, we're going to bring in our I, and then it becomes a square root of a positive 81. Just a reminder, back when we did the lesson, we went into detail about why that is. Basically, if you're square rooting a negative 81, we can break that down into the square root of a negative 1 times 81. And then we can break that down to a square root of negative 1, square root of 81. And this square root of negative 1 is what I is equal to. So I square root of 81. So once we get the hang of that, we jump from this to this right away. Now that we're square rooting a positive number, we can actually square root the 81. Square root of 81 is 9. So x is equal to positive or negative I times 9, or we'll just say 9i. We like to put the number in front of the I. Number 18, x squared equals negative 144. To solve for x, we'll square root both sides. Square root of x squared is x equals, don't forget your plus or minus. And then when we're square rooting a negative number, we bring in I and work with a positive square root. Again, following this math up here, but we can just jump right to that. And then the square root of 144 is 12. So x equals positive and negative I times 12, or just a 12i. All right, number 19 and 20, we are just simplifying these. We want to be very careful that we are looking closely and recognize that this is just an addition problem and this is just a subtraction problem. There's no multiplying happening here. Often when students see two sets of parentheses, they want to start multiplying this whole thing out, but that is the wrong operation. We have no chance of getting the right answer when we do that. When it's just an addition problem, we just add the like parts. So this negative 2 will add with the 5. Negative 2 plus 5 is 3. And then this positive 3i will add with a negative 2i. So 3i plus a negative 2i is a positive I. And there's our answer. Number 20, now subtraction is the one to be careful about. That one students tend to make more mistakes on. My advice there is if you put 1 in front of that second parenthesis, now you can see that you're going to distribute a negative 1, leaving you with a negative 6, and then negative 1 times negative 7i is a positive 7i. You can even bring down the first complex number, 8 plus 5i, and now you're just combining like terms. Because when you distribute the negative 1, you're taking care of the subtraction piece. And now we can just look for our like parts. We have an 8 minus 6, which is positive 2. And then, 5i plus 7i is a positive 12i. All right, number 21. Now this one is multiplication. We have a complex number, two terms, binomial, times. So see those parentheses right next to each other. That indicates multiplication. And I know that you guys know that. I just think we're not looking careful when we miss this plus and we miss the subtraction. So just make sure you know what operation you're working with. All right, so this just means we're going to distribute. 4 times negative 5 is negative 20. 4 times 4i is a positive 16i. Now let's distribute the negative 3i. Negative 3i times negative 5 is a positive 15i, and negative 3i times 4i is a negative 12i squared. I times I is I squared. All right, so we have some simplifying to do. We've got the negative 20 out front. These are like terms. 16i plus 15i is 31i. And then minus, anytime I squared shows up with multiplication, I squared is equal to negative 1. So instead of 12 times I squared, it's 12 times a negative 1. And that is let's see, switch colors. That ends up being a negative 12 times a negative 1, which is a positive 12. All right, so now we just created some like terms. Negative 20 plus 12 is a negative 8, and we'll carry down our 31i, and there's our answer. Okay, number 22. We have a fraction that has this negative 2 plus I in the denominator. We've learned throughout math that you cannot have square roots in your denominator. This I in the denominator, because I represents the square root of a negative 1, this is not okay. So we have to fix that. That's the issue with this problem. So what we do is we multiply the denominator, this negative 2 plus I, by its conjugate. Now a conjugate is it's still going to be a negative 2, it's still going to be an I, but this sign in the middle, this plus, is going to change to a minus. So we're going to multiply that by a negative 2 minus I. If we multiply the denominator by that, we multiply the numerator by negative 2 minus I. And then we'll just multiply these out. And in the end, we should no longer have an I in the denominator. Actually, we're going to get this down to a single number in the denominator. But numerators, easy place to start. We're just going to distribute. 3 times negative 2i is negative 6i. And then 3i times a negative I is a negative 3i squared. Now we know we're going to deal with that I squared. We'll just come back to that. That'll go over. Now let's multiply out the denominator. We've got negative 2 times negative 2 is positive 4. Negative 2 times a negative I is a positive 2i. I times negative 2 is a negative 2i. By the way, when we change this addition to subtraction or vice versa, this will happen every time. We'll always get two terms that will add up to 0 and we end up crossing off. And then I times a negative I is a negative I squared. So again, I squared is showing up there. Let's go ahead and simplify this denominator. We just said that 2i minus 2i is 0. So we have 4 minus I squared. But we did just say that I squared is a negative 1. So we have 4 minus negative 1, which turns to addition, which is 5. So we have a 5 in our denominator. Now up here, we've got an I squared. So this is a negative 3 times I squared, which is negative 1. So negative 3 times negative 1 is positive 3. And so we have a 6i and a positive 3. The way that we'll write that is we'll write the 3 first minus the 6i all over 5. And then can we simplify this any further? Can the 3, 6, and 5 all be reduced by the same number? And because they can't, we'll just leave it like that. All right, 23, solve each quadratic equation by completing the square. So completing the square is a method we can use to get a quadratic equation into vertex form. And once we have it in vertex form, then it's easy to solve. So this is, when you guys are solving on the test, you do have a choice. You can choose your method of solving. And some people like to solve with completing the square because once you have vertex form, it's easy to solve or feels easy to solve a quadratic equation. So here's how completing the square works. We want to get our c value to the other side. So we have n squared plus 10x plus, we're going to complete that square. That's going to be equal to 1 on the other side. Now, what number are we going to add in here? We want to add in a number that will give us a perfect square trinomial. This will be something we can factor. So we take our b value of 10, we divide it by 2, and we square that. That's what goes there. So that is going to give us a positive 25. And then to keep our equation balanced, we're going to add 25 to the other side also. So this is factorable, x squared plus 10x plus 25. Factors of 25 that add up to 10 are 5 and 5. So we'll say x plus 5 squared equals 1 plus 25 is 26. Now, here's our x right here. There are no other x's in the equation, so that means that we can just essentially undo all of these operations to get the x alone. But it's locked in with that parentheses. So first thing we need to do is square root both sides. The square root cancels out our square, leaving us with x plus 5 equals. Now, because we just square rooted, that's going to give us two answers. So that's where your plus or minus comes in, square root of 26. Now we can get to the x. We'll subtract 5 from both sides. So x equals a negative 5 plus or minus the square root of 26. All right, so let's try another one of those. If you guys get the hang of completing the square, again, once we completed the square, we got to solve this equation. We just square rooted and subtracted 5. We essentially did that in 2 steps. But it's just a matter of getting comfortable with this process. So let's try another one. We want to get the x squared and x terms on the same side. So I am going to subtract this 3x over here. I can see this 11 is already on the side I want it to be on, so I'm just going to leave it over there. So we have x squared plus 2x. Here I am going to add in that space because I know I'm going to fill something in there that's equal to 11. All right, we want to create a perfect square trinomial, so we take our b value, which is 2, we divide it by 2, and then square it, and that's what we're going to put in here. 1 squared is a 1, and let's make sure we add 1 to the other side of the equation as well. All right, we just created something that we can factor. What are factors of 1 that add up to 2? That is going to give us 1 times 1, or x plus 1 squared equals 11 plus 1 on the other side gives us 12. All right, so let's solve this equation. We'll square root both sides. The square root cancels out the square, leaving us with x plus 1 equals. This is where our plus or minus comes in, square root of 12. We'll talk about that square root of 12 in just a second, but let's keep solving for x. We'll subtract 1. So x equals negative 1 plus or minus the square root of 12. Now, square root of 12, I guess I did not talk about this on the previous problem just because square root of 26 doesn't reduce, so I didn't even try to because I just already knew that. But square root of 12, we can reduce this radical. When we reduce radicals, we want to think, does 12 have a perfect square that's a factor? And it does. 4 is a factor with 3, 4 times 3. And then the square root of 4 is 2, so we're able to reduce that radical. So x equals negative 1 plus or minus 2 root 3, and there's our final answer. All right, so if completing the square is still making no sense to you, can we solve the quadratic equation with any other method? And you can. That's what our quadratic formula. This is your backup plan for solving any quadratic equation, but just keep in mind if there's an easier way, then take the easier way. Quadratic formula is not always the easiest thing to do. Like for example, I talked earlier how I prefer to factor. If I can factor it, great. For this example, there is a number in front of our x squared, 3. first I might try to see, could I divide everything by a 3 to reduce my equation? We can't, so the 3 is stuck there. I could possibly try to factor this with guessing and checking, but that is complicating the factoring. So um, if I don't feel like guessing and checking, then I'll just go right to the quadratic formula. So quadratic formula, you guys all know the song. So let's just write it out. We've got x equals plus or minus, nope, I need to sing it, right? What is it? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, as long as we know our a, b, and c, then we can plug this in, and we just want to be very careful about our simplifying. So x equals negative, I always put a parenthesis and then look to see what the b value is. In this case, our b value is just a 2. Plus or minus the square root. Now b squared, our b value is 2. Always put your b value in parentheses, because if your b value is negative and we don't put it in parentheses, we're probably going to end up with a wrong answer. So there's b squared, oops, minus 4ac. So a is 3 and c is 1. All over 2 times a, which is 3. All right, so from here, what I like to do is we have our negative 2 plus or minus the square root of. Let's get that down to one number. And I'll be honest, I just grab my calculator and I type it in. I type in a 2 squared minus 4. I type in all the parentheses I wrote, and I'm getting a negative 8 all over 6. All right, so for this particular example, we're getting a square root of a negative 8. So this is a non-real answer. This will be an imaginary solution. If we were to graph this, um, if we were to graph this on our calculators to see where it crossed the x-axis to find solutions, it wouldn't cross the x-axis. We'd say, oh, there's no solution. That just means there's no real solution. But we can keep working with this to get our imaginary complex solution. So when you square root a negative, remember that's when I shows up. So we have negative 2 plus or minus I times the square root of 8 all over 6. And then now that 8 is positive, can we reduce the square root of 8? Well, yeah, we can do 4 times 2. So that's a negative 2 plus or minus. We have the I, and then square root of 4 is going to give us a 2. So we'll put the 2 first, then the I, and then square root of this 2, I'm just going to carry down, all over 6. All right, so from here, we can simplify this a couple ways. I don't know if it's just going to be easier to think about separating this into two fractions. We have negative 2 over 6 plus or minus 2i root 2 over 6. Why we want to do that is, is because we can reduce this. Negative 2/6 reduces to negative 1/3 plus or minus, and then this 2i over 6, anything outside your radical, we could reduce. 2i over 6 reduces to a 1i over 6. That 2 over 6 just reduces to 1 over 6. Or we could just say I root 2 over 6. So that 1 would be with the I right there, but it's just not necessary to write. All right, that one got a little bit fancier with our simplifying, but we did it.